Kawasaki Heavy Industries has debuted its K-RACER-X2 VTOL UAV at the Japan Aerospace Exhibition in Tokyo, emphasizing its maritime and cargo transport capabilities. Look at that thing. The K-RACER project, which was initially aimed at high-speed UAV development, has pivoted to meet the demand for heavy cargo transport, leading to the K-RACER-X2. This UAV is actually able to carry up to 200 kilograms, cover on over 100 kilometers, operate at altitudes of around 3,000 meters, which is pretty ideal for mountainous logistics and disaster relief. Sounds like earlier this year in 2024, there was a test involving supply delivery from pier to ship. So there might be some future naval applications here as well. I mean, sounds like they're also integrating sensors, communication tools, along with the JMSDF's upcoming research on the horizon detection using UAV mounted radars starting really later next year.
So this project originally began with the K-RACER to develop a high-speed unmanned aircraft. And during that development process, it became clear there was now a demand for heavy cargo transportation, which is why we have the K-RACER-X2. This shows what can happen in development when you're testing and have a testing and change process that you now integrate, into your design. It integrated into or became a different functionality. So the K-RACER-X2, as you said, it can now do heavy cargo. It might have defense cases, might resupply moving Navy vessels, can be used to detect targets beyond the horizon. I think this just shows that testing and figuring out your use case and being able to pivot those requirements. That's the challenge of this design process here is can we've already got momentum going. Can we and should we pivot? And the should we is a part you got to figure out how to develop. Like it is a decision you've got to make too.
Number one, scalability for multiple use cases. The challenge here isn't just defining that use case, it's actually ensuring that that K-RACER can be scaled and adapted for various missions from cargo to potential defense applications without needing to fully redesign every single time.
See, I don't think it had to be a full redesign. I think it was just a partial redirect because you can still have the K-RACER and it's, you just branched your process here. And now you're figuring out, okay, we also have this use case. Let's make this happen. So I think more use cases are going to come up. I think they're going to find more use cases for how we're going to use this because, we've mentioned how this whole, industry of what's happening with any kind of vertical takeoff is something that is becoming, it's going to infiltrate society. Basically, it's going to be everywhere. And I think we're going to find more use cases. And then how do we make our process, our DCM work with that?
Yeah, I think you're leaning into the solution here, which is going to be product structure and configuration management. I think that's going to be the big solution, so that you can modularize and make it even more adaptable with multiple configurations that suit different missions. We're talking about a plug and play versatility without compromising performance. So I think we're both lining up on the overall solution. But the question will be, what about AI?
Yeah, I mean, I think AI could definitely be used to help figure out what kind of or what needs to be modular, what kind of modular components do you need, the configurations to figure out the best way to configure things, the quickest, the cheapest, the easiest for users to actually go and make these changes from cargo to defense with minimal reconfiguration time. So it's really just finding a way to make everything adaptable at speed.
Adaptability at the speed of need.